I'm going to go over how to run a t-test for dependent samples in Microsoft Excel. Here we have some data from people who participated in a program to increase tolerance for ethnic differences. And you can see we have a pre-test and a post-test. So I have the same group of people being tested at two different time points. So they take the test, they engage in the program, and then they take the test again. So this would be dependent samples because each person in sample 1 is related to themselves in sample 2. So the same person at different time points would make it a t-test for dependent samples. So there's two ways that I can do this in Microsoft Excel. The first way would be to use the functions. So I'm going to run this with the t-test function. And I don't need to type this in here, it just helps me keep track of what I'm doing. So I'm going to come up here to the Insert Function button. And t-test is showing up for me because I just used it recently. If it's not showing up for you, you come up here and delete this and type t-test here to search for it. So the first thing I need to do is enter my first array of data. I'm going to tell it where that data is located at. And then select my second array of data. And for some reason it's saying table instead of actually putting the data in there. I don't know why it's doing that, but I can also just enter this in manually. So my data is in A2, and then I put a colon A25. So I tell it where it starts and where it ends. So if it's doing anything weird like that to you, you can also always just put it in manually. So A2 to A25 and B2 to B25. Then I need to tell it how many tails. So this is whether it's going to be a one-tail or a two-tail test. I'm doing this as a one-tail test because I want to see if people get better when they participate in the program. Maybe the program actually reduces tolerance to ethnic differences and people hate the program so they're less tolerant. That wouldn't be very helpful. So I need to know if it's going to actually increase. So a directional hypothesis makes more sense to me. Then I need to tell it what type of t-test. I use the same function for an independent sample or for a dependent sample. So I tell it here which test to run. And with the dependent samples, here it's called paired, which is equal to 1. So I'm going to put a 1 in here and click OK. And that gives me 0.079, which is going to be my one-tailed p-value for this test. Okay, so now let me run it using the Data Analysis Toolpack. So I'll come up here to Data and go over to Data Analysis. These are the tests that I've used most recently. I just did a 2-sample test, but in this case, I want to do the t-test for a paired sample. And you'll note I don't have to choose whether there's equal or unequal variance because each person in my sample has a match, which is actually themselves. At the second time point, that data is already paired, so I don't need to consider the variance between the samples. It's already taken into account that those are going to be, each person is going to be more similar to themselves than to other people. So I click OK. And I need to tell it where the data is located. So I'm going to select the data range. And I'm going to go ahead and select these labels because when we run tests, it helps to have the labels to be able to do the interpretation. And it helps more when we get into the more complicated tests, but I'll just go ahead and select that. You'll note that I left this hypothesized mean difference box blank. If I thought I knew what the difference was, like maybe there's a 5-point increase, for example, I would put that here, but most of the time you're going to just leave this blank and it works just fine. Significance level of 0.05 is going to be great for me. I'm going to go ahead and use that. And then I need to change the output range because I always like to have the table somewhere near my data rather than on a different spreadsheet. So everything looks good, so I'm going to go ahead and click OK. And I get these results. Just widen that a little bit. Okay, so this gives me my mean for both groups. It gives me my variance for both groups. And it also gives me the number of observations. And it gives me the degrees of freedom and my t-test statistic, as well as a one-tail and a two-tail p-value for my results. So you can see I get a lot more information from the analysis tool pack, and so that's going to be a good way to run the test. So to interpret this result, let's go back and look at the mean. So the mean for my pretest was 31, and this is on a scale of 50 being the highest possible value, a higher score indicating higher tolerance. So you need to understand your data to make some interpretations. So there's a difference between the means. I can see that the post-test, there's a much higher mean, so it looks like it is increasing. Their tolerance to ethnic differences is increasing. But that didn't tell me if that difference was significant, so I had to run my t-test to see if this is a significant difference. So let me come down to my p-value, and I'll compare this to the significance level that I chose for the test. And if you remember, our significance level that we chose was 0.05. I'm just going to put this in here for reference. So my significance level is equal to 0.05. So if I compare this p-value to my level of significance, it's lower, which would tell me that I would reject the null hypothesis, that there is no difference between the groups, and conclude that there actually is a difference. And that would mean that this increase that we're seeing is a significant difference in the increase. So the program is statistically significant at increasing tolerance to ethnic differences. So now you know how to run both of the options for a t-test for dependent samples, the functions, and also in the analysis tool pack. And again, you get more information with the analysis tool pack. So that would be my preference if you have that available to you.